G'day, g'day, g'day. Mr. Bishop, we're back.
Back to another episode of Bish Dog Maths. This time we're tackling factorisation.
Into it. Living the dream, love factorisation. It's great.
For this one's mainly year 10s, but it comes across all year groups of maths. But right now we think of the year 10s.
And we had this good little infographic we found in the book. We saw that going from this sort of formula, like A times B plus A times C, back this way is factorising, putting it outside brackets.
Life cycle.
It's like a life cycle. And then going back from this through distributive law, expanding it back out to what it originally was. Okay, so today we're going to be looking at factorisation. So I'm just going to rub this off in the traditional fashion, as we do. And we might look at something that we were looking at in the book a moment ago that was 6x plus 9. Now, how do we tackle that? How do we factorise that? What are we looking for, Mr. Bishop?
Well, you butt in if I'm wrong, but I'd be looking at the old HCF.
HCF.
Common factor.
HCF. That's not one of those health insurance funds, is it?
No.
No, it's not.
It's
Highest.
HCF.
I think there is an HCF though, but anyway, that's fine.
Okay.
Never mind. Talking points. Highest common factor.
Yeah, highest common factor between 6 and 9.
So they're looking for the biggest number that
Yes.
goes into 6 and 9.
It's the biggest number I could use in my times table to do. For example, 1. 1 times 6 is 6, and 1 times 9 is 9, but that's not the highest.
No. And
Okay, and then I can go, okay, what about
right.
What about 2?
2? Yeah, we'll try 2.
2 times 3 is 6, perfect.
Yep.
2 times 4 is 8, 2 times 5 is 10, I can't get 9.
2.5, isn't it? Oh, sorry, 4.5.
Yeah, 4.5.
4.5
But
times.
sorry, you need a whole number. Highest common factor is a whole number.
Whole number.
You can't do decimals.
Whole number.
So, I'm thinking 3.
3. Okay, beautiful. Let's try 3.
Yep.
Right, 3. And we're going to put a bracket and a bracket like that. So we're going to pull 3 outside of this. So how many times does 3 go into 6?
Twice.
Twice. So we put 2. And then what do we do with the x?
Well, this guy's got an x, but this guy doesn't have an x. So the x has to be on the inside of the brackets.
Because that's not in the highest common factor
But
scenario.
if that was a 9x, we could put 3x here.
Ah, okay, then we could pull the x out.
But it's not. So one of them has it, so we can't include it.
Okay,
and then I'd go 3 to get 9. 3 times 3.
3 times 3?
And it's a positive.
Plus 3.
Yeah.
So 3 outside of 2x plus 3
Yeah.
is how we factorise that one.
Yes.
Okay, right.
Because if you over the last video, somehow we can link it. 3 times 2x is 6x. 3 times positive 3 is positive 9.
And we're back to that.
Yeah.
Expanding.
Would Mr. Keyworth call the office, please? Mr. Keyworth?
There you go.
Still happening at school.
This is live.
Live.
Yeah.
It's live. Anyway, that's fantastic. So that's factorising.
Yep.
And that's distributive.
Yeah. Goes back. Yeah. Okay.
Distributing back up to that.
Hey, should we factorise this?
Yeah, we could do. Anyway, better watch my new board.
Yeah.
Anyway, okay, next one. What was the next one we're going to do, Mr. Bishop? I think we'll grab that back there. And we might even scan a couple of pages in from the Dwight experiment.
8x to the power of 5.
8x to the power of 5.
Yep. Minus 12x to the power of 3.
Whoa. Is that, yeah?
Yeah. That's next level.
It's up there. Yeah. Okay, that's pretty full on. That's a bit of a jump, but that's okay. We'll go through this at the moment. So what would be what can we think of in terms of highest common factors there with the numbers we got in front of us?
Well, I know 2. 4 times 2 is 8, and 4 times 2 is 8, or 2 times 4 is 8, and 2 times 6 is 12.
Oh, so we'll just do 2 then.
We could.
could.
That's a factor.
But is it the
biggest one we can find?
No, it's not. No.
So is it a bigger one?
Okay. Thinking of my 8 times tables, thinking of my 12.
What about 4 times 2 is 8?
4 times 2 is 8.
4 times 3 is 12.
Yeah, I think that's good.
Yeah, because you could go, 8 times 1 is 8, but 8 doesn't, you can't give it 8, 8 is 16. So 4 is the biggest number we can have.
Okay. The big guy out here, and then some brackets. Okay, and we just put the brackets in because that's kind of the next step.
Yeah. So 2 would work, but it's not the highest.
Okay.
So you want to make it more efficient.
Yes, go straight for the highest common factor.
Because highest factor there means smaller numbers here.
which is what we want.
Simpler, yeah.
Yep, simples.
So, also,
We've got some x to the power of
Yes.
5, we've got some x to the power of 3. Should we worry about the big numbers first in front and put them in?
yep, okay, let's
Yep.
do that.
So 4 goes into 8 how many times, Mr. Bishop?
Twice.
Twice. Okay, and we'll leave some gap for some mathing, and what I might do is put the bracket out here somewhere just so we get a bit of room.
Yeah.
And we can tidy it up and write it nice and neatly down here with a big, tick next to it afterwards. Now, 4 into negative 12. Negative 12.
Well, now that you just think of 4 into 12 is 3.
3.
3 fours are 12.
Yeah.
Now, positive to negative. What do you
Positive to
wanna do
negative
there?
is going to, well, that's going to create a negative in here,
Yeah.
isn't it? Yeah. So it'll be a negative 3.
Yep.
Okay. So we've got our whole numbers.
Yep.
And we've got our non-algebraic numbers that we've put in there
Now we can deal with the
first. The unknowns.
Yes. Now that's x to the power of 5 and x to the power of 3.
Okay.
Now don't think of them as factorizing. Just put the smallest number here.
The smallest
and
x
then,
cubed. Yeah.
multiplying index laws.
Yeah. So we might give a bit of room in front of that 4 because we jumped the gun a bit before.
Yeah.
Okay. Yep.
So I would put x to the power of 3.
Yeah.
The smaller one right there, and then he's done.
X to the power
You
of
don't have to
3 here.
give 3 an x.
Okay. Because
So
this
4x to the power of 3 times negative 3 would be negative 12x to the power of 3.
Okay.
And then you're like, well, wait, hang on a minute. You can't. 3 doesn't go into 12. 3 times 2 is 6. But it's index laws.
Yeah, we're doing index laws now, so this is why it's a little bit more complex than the other one. we
It
did.
doesn't apply, or it does. As in, you just add the indices when you're multiplying indices.
Yes, add the indices
Yes.
and multiplying them. Yep.
So, 3, how many more do you need to make 5?
2.
2. So,
2.
x to the power of 2.
X to the power of 2.
And now, when we times this, you get 4x. Well, 4 times 2 is 8. And then, when you times x to the power of 3 times x to the power of 2, when you're timesing indices, you may remember you actually just plus the indices. Okay, so it's 3 plus 2 is 5.
So if we were to try and expand this out just to check that we got the right answer, we're not sort of
Yeah.
outside the flags doing the wrong thing.
Yep.
We've got 4 times 2 is 8. And then x to the power of 3 times x to the power of, that should have been 2.
Yeah,
Mr.
2.
Davies made a mistake there. It does happen on occasion.
On camera.
On camera.
Rare event.
Done. X to the power of 3 multiplied by x to the power of 2. So that's x to the power of 3 times x to the power of 2. We add the indices. It's x to the power of 5. So 8x to the power of 5. And then minus, because you've got this minus
Positive
shenanigans
times
going on
negative
here.
is a negative.
Positive times a negative. So 4x cubed times minus 3. What's 4 times minus 3, Mr. Bishop?
That'd be minus 12.
Minus 12. And then x cubed times whatever would have been there, which at the moment is probably just 1.
Yep, so it'd be x cubed.
Cubed. And then that is
Yeah.
equal to that.
The
And we
fact,
checked our
the
answer.
fact we get back to the start means that's the answer. That's correct.
That's correct. Yeah.
So well done, Ms. Davies.
Yeah. So what we'll do is we'll put some of these up on
Yeah.
up on Connect, so you can have a look from the textbook. They start off a little easier like the previous
Yeah.
ones we did, and they get a little bit more complex like this one. But this should be a good grounding for you to sort of get into this anyway. And then we'll talk
Yeah.
about why we factorise afterwards
Yeah.
in quadratic equations, why that's important.
Many
That's the
videos
next
to
step.
come.
Anyway, awesome. Thank you.
Thank you.
See you, folks.